All attendees are in listen-only mode.
All right, good morning and good afternoon, everybody. Welcome to our webinar series on grand challenges that we face in metabolomics. This is our second presentation, and today's presentation will focus on metabolite identification. My name is Lloyd Sumner, and I will be your host and discussion leader for today. Behind the scenes are Dan Bearden, who is helping us with the logistics and hosting this as part of the Metabolomics Society efforts. And also behind the scenes are Sutanika Ray, who will be helping us with the logistics of the webinar. So hopefully everybody can hear me, and hopefully everybody can see my presentation screen. If you would, maybe give us a couple of tweets back or in the chat area to let us know that you can see and hear things. So again, this is a second in a series of webinars that we are hosting to really focus on, talking about the grand challenges of metabolomics. Today we'll focus on metabolite identification. Last month we focused on, introduction of this webinar series, and then next month Oliver Fien and Peter Dorstein will present on the topic of developing enabling metabolomics databases and computational infrastructure. And essentially, we will work our way through these grand challenges with independent discussions. So a few comments about the webinar logistics. So first, please sign in with your full name. I see that many people have done that. The only way to do that after you've logged in is to log off and then re-sign in with your name. But we ask that you use your name now and in the future to give us a better accounting of who's online and for our records. So in your menu for webinar or GoToMeetings, we ask that you ask the technical questions in the chat area. And again, Sutanika is back here to help with that, and Dan will be backing her up if you have any questions about audio, video, logging on, things of that logistical nature. For scientific questions, we ask that you use the attendee window, and specifically there is a question, little box up here that you can write your questions in, and or there's another box that you can check to raise your hand. For the first 15 or 20 minutes of this, we do have a specific presentation that will introduce some topics for discussion, and after that point then we will begin to unmute folks, answer questions and ask questions, or in reverse order of that. So again, our goals are today to talk about some of the grand challenges, and specifically metabolite identification of a grand challenge. I have about a 15 or 20 minute presentation to kind of introduce the topic and to stimulate discussion. But we really do want feedback from you. We want discussions, we want questions, and that's what this forum is. And we want this to be a discussion forum that helps us vet the ground challenges and the challenges that we face specifically in metabolite identification for today, and then help us to prioritize these challenges that we face, with ultimately trying to build some community consensus as what are the major challenges, what are the minor challenges, and how can we join together to begin to solve these challenges. And hopefully through the meeting today you will see others online that you can network with, and or to help start building solutions to these grand challenges. And truthfully, most of the grand challenges are not going to be resolved by an individual person or lab. That is going to take community efforts to do these, and some, especially in the area of metabolite identification and metabolome cataloging, if you will, we expect to be a large international effort. So one of the unique things that happened last week is Dan was able to put together some poll questions. And essentially we had put together a list of grand challenges and kind of ranked them based on some previous community discussions and input. But essentially last month we were able to get a better quantitation of this. And essentially we had 100 people online, or 100 people online, that provided quantitative feedback. And essentially we were able to score all of the different grand challenges that we discussed. And what that allowed us to do was then rank these based on that quantitative feedback. And it was interesting to see the results. And so they're kind of in reverse order of lowest priority to highest priority at the bottom. And essentially the number one challenge is still holding to be large-scale metabolite identification. Many of the others seemed to fall in line where we expected them, but there were a couple of interesting moves. And so, for example, data interpretation moved up from number 4 to number 2. And actually that's kind of interesting because metabolite identification is also very important for data interpretation. The raw process data is just peaks and numbers and chromatograms, but once you place a metabolite identification to it, you actually provide a biological context from which interpretation can come from. So, and again, it was interesting to see that interpretation move up, but it was also reassuring to see that metabolite identification is still a grand challenge of primary importance. Other things that moved up that were a little surprising is understanding the exposome and environmental impacts on multiple organisms and humans especially. But we will use this information to help structure our webinars in the future, but today we're going to focus in again on the number one challenge, and that is metabolite identification. So we have some, few questions that kind of come up when we start talking about metabolite identification, and essentially these resolve around what tools are you using for metabolite identification, what really constitutes a confident metabolite identification, how should we report this information and this confidence to others in the literature so that our data can be reused successfully and with confidence. What nomenclature should we use for metabolite identification? There's many different nomenclatures out there. There's IUPAC, there's common names, and then there's database accession numbers, things of that nature. So can we talk about what we should use and vet that more today? And then finally, how do we accelerate and scale up metabolite identifications? If there are hundreds of thousands of different metabolites in the plant kingdom, for example, how do we identify all of those in a timely manner? And that then in of itself is a major challenge. So what tools do we use for metabolite identification? Most of the metabolomics community typically uses some form of mass spectrometry and or NMR for their profiling. This can be in the form of ICP, MS for ionic components, metals, charged particles, things of that nature. Others use GCMS. Most of that is predominantly focused on primary metabolism. Many in the plant community use LCMS for secondary or specialized metabolites. It's also used, for example, for primary metabolites in Hillick or based type of chromatography. And then many use NMR. There are many other tools that are used, for example, UV absorbance type chromatography, but the differentiation power of some of those other tools are not near as specific or selective of that of mass spectrometry and NMR. Therefore, these tools have risen to the top, but if you would like to argue the case for other technologies, we would welcome that feedback. So what tools additionally do we use for metabolite identification using this equipment? Many people do this in a flow injection type of mass analysis. Others will use some type of coupled chromatography via GCMS or LCMS or UHPLC-MS to get additional orthogonal data, i.e. in the separation or chromatography domain. Many people that do chromatography also couple these with other online type of detectors, including mass spec, UV absorbance, some electrochemical type of detectors as well. From these data come accurate mass measurements. Again, we can obtain tandem mass spectrometry data, we can obtain proton data or carbon NMR data, or even other element-specific type of NMR, such as phosphorus NMR. And often the NMR is coupled in a 2D manner, either proton-proton or proton-carbon or other nuclei. So moving quite rapidly through this discussion, we then move to the next question: what constitutes a confident metabolite identification? And this has been discussed somewhat through the community before, and we're going to dig into this in a little bit more depth as we go. But essentially, the generally accepted standard right now is that you have a minimum of 2 orthogonal data types relative to an authentic standard for a confident identification. And typically, this is used for identifying known unknowns in our metabolite profiles, i.e., when we do the profiling, we see data. At that point, we don't know what it is, but we ultimately, when we get an authentic standard, we're able to confirm that as a known compound. And so this is often referred to as dereplication, if you will. But we also deal with true unknown type of compounds. And for these are novel molecules that have not been seen before, that have not been reported, that are not in databases. And the precedence for identifying these with confidence has been vetted for over 100 years through the chemical journals. And essentially, their requirements are fairly straightforward. Most of them require evidence of homogeneity or purity, suggesting that they do believe that it's important to purify a compound prior to obtaining additional evidence for its structure. And these evidence often include accurate mass or high-resolution mass data from which an elemental formula can be predicted or elemental analysis can be performed directly. In addition, the journals typically require 1D proton and carbon NMR. If the compounds have chiral centers, they will often require some type of evidence of that chirality, often that being circular dichroism measurements and or possibly chiral type of separations with authentic or synthetic standards that were created to identify that or to confirm that identification. So how should we report our metabolite identification confidence? Well, first, this is a very important subject, and many in the community are demanding, and that the growth in that demand is substantial, and that they're asking authors to provide more information on their identification confidence and the means for the identification. And that's really so that they can reuse that data and or ask more challenging questions of that data. And this is actually beginning to permeate into the journal requirements. And so now, for example, the Metabolomics Society Journal Metabolomics requests this type of information when you submit a manuscript. And so this topic of identification confidence has been going on for some time, and this started or was formalized back in 2007 when Oliver and his group spearheaded the efforts to lead a metabolomics standards initiative, and this was published in the Metabolomics Journal in 2007. And from that standard initiatives, there were several groups, and we were actually involved with a large number of others in deciding on the reporting standards for chemical analysis, and this actually included metabolite identification and confidence levels that would be associated with them. More recently, Darren Creek has also reinvigorated this discussion through the Metabolomics Society Task Group on Metabolite Identification, and began to ask the questions, well, where are we now? What are your confidence levels? And how do your peers gauge this confidence? And then more recently, we wrote another article proposing a quantitative and alphanumeric type of metabolomics identification metric that one might use to convey more information on metabolite identification. So again, the take-home message is that we believe that there's a real need to report identification confidence, and this discussion has been going on for some time. But there's now been a push to revitalize this discussion and then begin to act more on these types of requirements or recommendations, i.e. incorporate these in publication requirements. So all of these references are available online in the Metabolomics Journal, and there's a link here if you are interested in accessing them. Many of these, especially in the 2007 issue, I believe are open access or freely available. The more recent ones may not be. You may need a subscription to those journals to get access to them. So Again, we encourage authors to report their identification confidence, and the idea is that there's been a numerical scale proposed for this, and this has come out of the early work that the Chemical Analysis Working Group put forward. And they divided the identification confidence into 4 simplified levels. One is an identified compound, and that was described as based on 2 orthogonal data types relative to an authentic standard. The next is putative identified compounds that we lack the chemical reference material, but we have a lot of spectral or physical chemical properties that we can use to base that identification on, and or we match to other commercial spectral libraries from other instruments or other sources. Then the third class is putatively identified compounds, i.e. compounds that we can put in a certain chemical class based on spectral similarity or spectral properties that can help us classify them, i.e. as an amino acid or a monosaccharide type thing, but we can actually put a full chemical structure to those. And then there are the unknown compounds. We can still differentiate these based on retention and mass, but we don't actually have a qualified identification for them. And so this original proposal was very basic and 4 levels to that. So more recently, there's been some questions about those levels, and do they cover all of the needs of the metabolite identification? And so the Metabolite Society put together a metabolite identification task group, and this was then reported in a paper by Creek et al., which I already mentioned. And the goals of this metabolite identification task force is 5 objectives. They want to build consensus and further develop reporting standards with input from others from the community. They want to educate the community about these issues and such as we're talking about right now, the identification reporting standards and what constitutes confident identification. Then ultimately we want to see these move into some type of application, i.e. to ensure that the reporting standards or suggestions are then adopted by journals and the community, and that people begin to add more information to their data set to ensure that that data set is then reusable by others and meaningful to others. And part of this is also to educate and provide information on current tools, and that's kind of what we're talking about. How are we doing things now? And to provide a forum for discussion. And then provide opportunities for us to work together. There's been an identification challenge, CASME, that's gone around to allow people to test their skills. And we would encourage participation in that. So the Creek et al. Really, questioned the idea, about the 4-level system, and they said, do we need to develop sub-levels to this, because those 4 levels do not meet all of the criteria? Should we develop some type of quantitative scoring system in place of the 4 levels, or should we actually use a quantitative scoring system in conjunction with the 4-level system put forward by the earlier Metabolomic Standard Initiative and Chemical Analysis Working Group? And so the idea is where are we at now? How do these current 4 levels serve us, and can we make them better? And so I think there is substantial consensus that the 4-level system is very simple and easy to use, but it doesn't cover all of the space. And so the idea is, could we expand that into a more elaborate level system? And this has been reported, and a suggestion has been made by Szymanski and colleagues. And essentially it now goes to a 5-level system with some sub-levels in some of these. And so, you can read as well as I can talk about it, but the first level stays the same. It's conferred structures based on co-characterization with reference standards. Then they break it down into a few other levels to level 2 being probable structures, and then based on the criteria, well, did that come from a spectral match, i.e. to commercial libraries, or by other diagnostic evidence? And then we have tentative identifications, unequivocal, just molecular formulas, and that the basis of this is an accurate mass. And so this is a very mass spectrometry concentric type of identification schema, but it is an expansion of what the original 4-level system was. And so by expanding it, there's a little bit more detail, but it is still fairly simplified, i.e. 5 levels with maybe a few sub-levels. The other alternative is to build a more quantitative reporting system where we use numerical quantitative values, or actually use some type of alphanumeric type of identifier of that confidence. And this is the quantified value is not a new concept, and essentially there is already in the public literature some evidence for these guidelines. And so the European Union has put together a guideline and a point system for identifying residues in tissues, and this is available online, and you can go look at that. But essentially what we did is we took this basic scaling system or quantitative system and expanded on it a little bit more to try to address many of the tools that are used in metabolomics or metabolite profiling. And essentially we tried to provide a subjective quantifier of value based upon, again, our subjective interpretation of the differentiation value of some of the technologies. So things that are very specific, such as NMR, that tell us a lot about the chemical structure in 3-dimensional things, have a greater differentiation, for example, than an IR absorbance spectrum. So there is a weighted system that has been developed. This is open for discussion, but it's a good place to start. And essentially, things that have low differentiation values have a low point value to them, but as we increase in the specificity and selectivity of the data, the value of that point system increases. And so then at the end of the day, when we have a metabolite identification, we just sum up the evidence for that identification. And if that identification is not matched against an authentic standard, then we simply multiply it by 1. If it's matched to literature value and spectral library type information from other sources, then it has a multiplier of 1.5. Or if it's matched to an authentic standard, then it has a multiplier of 2. This gets more complicated than the 4-level systems, but it actually is providing much more quantitative information. So just to run through a couple examples, if we have a metabolite identification that includes LC-MS or HPLC, MS accurate mass, high resolution retention time, and a match to an authentic standard, we would add up these individual things, such as an accurate mass, which is 1.0, a high resolution retention, which is 1.5. We then multiply that by 2 because it's matched to an authentic standard, and we come up with a cumulative score of 5. And you could do this for different technologies. If you have a GCMS with a high resolution retention time but nominal mass, i.e. quad, and then you match it to a NIST library, you get a quantitative sum of 4.2 or 5.25. And then, or if you have, NMR data, if you have a 1D spectra that's matched against an authentic standard, then you actually have a 4.0. And so examples, you could get 10 or even more point systems or point values through a rigorous type of identification process. So this is a way to quantify the evidence that's there for the identification. What the community has not done and will need to do is then decide what value, where is the cutoff line for a confident identification. Is it 5? Is it 4? Or is it 6 or 8? So right now I think somewhere around the area of 5 based on current standard, i.e. an accurate mass with a high resolution retention time. Those are 2 orthogonal data relative to an unknown gives us a value of 5. And so maybe that's a suggested place that we draw that line. Okay, so we talked about a 4-level system. We talked about an expansion of the four-level system. This slide presents a quantitative value, and there's one other possibility for the identification confidence reporting, and that is using some type of alphanumeric type of value. And that's what this slide does. It presents those. And more or less, it just uses abbreviations for the different technologies that were used in the identification. It puts a string of those together, and a lot of this is self-explanatory. For example, MS1 is just a full mass spectrum. MS2 is tandem mass spectrometry. If you have high resolution mass spectrometry data, i.e. accurate mass, 5 ppm or less with resolution of 10,000, then these become pretty simple, and we just string them together. For example, if you have proton, NMR, carbon-13. So for an example down here in the text is kind of busy, but if you have UHPLC EMS accurate mass data, this would be HRMS1, and high resolution retention time that were matched to an authentic standard, hence the subscript A, then that would be your numerical or your alpha numerical type of identifier. And if you were to add NMR data to that, that you then match to the literature, for example, you had a 2D HMBC that matched to a literature value, you would just add that to the string. And you would either add more or less information based on the identification, and then the user would be then charged with interpreting or defining for themselves what identification confidence they believe is there. So the community has been very careful not to demand a certain identification confidence from everybody. I think there's just more the desire for people to report the confidence that they have in their data. So again, people can judge how best to use their data. So then we get to a point asking the question, well, once we have the identification, how do we report that? I think it's very clear that for novel compounds that we need to use the full IUPAC nomenclature, but this is very, very long, and so many people often provide common names for them, and there's some examples in the paper that I noted earlier. But the problem then becomes, when reporting things, even glucose, for example, well, is that D or L type of glucose? And so how can we report the same compound so that we convey the full chemical information that we have? And there are codes out there now that have been developed, and the codes that have been used by IUPAC are the INCHI codes, and I think they're now INCHI 2 codes. But there are also SMILES codes or PubMed accession numbers that can also be used, and to ensure and to convey to others that this is the exact compound or the specific compound that we've identified. And using these codes, I think, are very beneficial, especially for the informatics people who can then take the data and parse it and use those codes in a much easier manner than they can certainly the IUPAC or the common name, and they can use it in a much more specific manner. But this is still open for debate. Should it be INCHI codes? Should it be SMILES codes? Or how do we ensure that we convey the most information that we can in the nomenclature? And then how do we scale up our metabolite identification process? And this becomes a real challenge. As I mentioned, there are hundreds of thousands of plant metabolites out there. How do we scale those up? Well, personally, I believe that we need ways to purify these metabolites in an automated manner. Well, we can begin to use integrated systems, LCMS, NMR. We're working in this area, and I saw Justin Vanderhoof online as well, and I know that he's done a lot of work in that area. We can begin to develop parallel systems, i.e. instead of having one LCMS system working at a time, that we actually have 2 or 3, or that we have 2 or 3 different labs working in parallel to resolve some of these identification challenges. There has also been great success in building computational tools for spectral interpretation and or prediction of structures, and there also are beginning to be numerous examples of success by building theoretical spectral libraries, then matching authentic data to those libraries as a putative identification. Those are predicted identifications, but at this point, many of the tools, some of the better tools, are proving to be very promising in their accuracy in predicting structures. But those will need to be validated much more, I think, before we have more universal confidence in them. Okay, so kind of bringing to a close the presentation part, we now want to begin to ask questions. And I've been very encouraged by being able to get quantitative information through polls online. So we just have a few questions for you, and actually I'm going to hand it over to Dan, and he's going to work through these type of online polls. We ask that you do vote and answer the polls. We ask that you do it in a timely manner. Typically, we only wait about a minute or so, so please be prompt. So over to you, Dan.
Okay, great. I hope everybody can hear me. When I launch the poll, it's going to change the screen, hopefully, and you'll see the poll. I'll read the question, and then you can start voting. So the first poll question is, do you believe a confident and trustworthy metabolite identification can be made based on an accurate mass to database entry?
On a match to an accurate base. Sorry, I didn't type the question out. Made based upon a match of an accurate mass to a database entry.
Right.
So please vote now. I'm not seeing my...
Yeah, we got 75% have voted. Moving on up, 81%. 83%.
Keep voting.
Maybe I didn't get an answer or write down an answer that people want. So we're at 87%. All right, that's pretty good. Let's close that one. Sorry, my screen changed. Let's go to the next one, which is, do you believe that a confident and trustworthy metabolite ID can be made based upon an accurate mass to database entry and tandem theoretical tandem match to a database entry? So combining accurate mass and theoretical. Okay, 75%, 80% voted. Okay, just a few more seconds. Ready, going, gone. All right. The third question is, do you believe a confident and trustworthy metabolite ID can be made based upon a single chemical shift assignment in NMR? So start voting on that one. %70 voted. Still racking them up. %80 voted. A couple more seconds here. Come on, one or two more people. We're at 88%. Going, gone. Oops.
All right.
One more.
And that's our three. Is there one more? Okay.
Yeah, one more. Do you believe a confident and trustworthy metabolite ID can be made based on an accurate mass to data. Wait.
That's just a repeat of
Oh,
the
okay.
first one.
All right.
So we asked 3 questions, and we should have 3 answers. And then in my slide set, I had we were going to kind of quantify and reveal the answers to that. So the first one, I think, based on what I saw, was a resounding no. But can you show the statistics that you?
Yeah, I think it's coming up.
Okay, so the audience can see it, but
You can't see it, Lloyd?
it's in my view screen, but it's very small.
Oh,
Can you read the results?
yeah. So this is the first question. Um, Metabolite ID based upon an accurate mass to a database entry. 12% said yes, 80% said no, 7% I don't know, and 2% said I choose not to answer. Okay.
All right. So I would say that that's a convincing general consensus of no.
Right.
And I think there's some evidence in the literature that supports that says that you can't usually get an unambiguous assignment based just on one accurate mass matching. So.
Okay. And then the next one is based on accurate mass to database entry. Well, accurate mass and tandem theoretical match. Yes and no is kind of split, both at 39%. I don't know is 17%, and 5% chose not to answer.
Yeah, so that's a little bit marginal call, and I too have some concerns there. If it was an authentic tandem match that you have in a library built by yourself, and if you also had retention time, then I would buy that because you would have 2 orthogonal data. But if it's just a tandem mass match, i.e. from maybe a flow injection type of experiment, then I would be a little bit more cautious.
All right. And then the results for the third question, based upon a single chemical shift. Only 7% said yes to NMR single chemical shift signal from NMR. 68% said no. 25% said they don't know. And 0% chose to not answer, or chose not to answer.
So I believe you had an opinion on this one. Dan, would you like to share your opinion?
Yeah, there's not enough caveats on this. I mean, an NMR person would never, if you have a singlet somewhere in the chemical shift spectrum, you just would never really hang your hat on it.
Mm-hmm.
But there's also just looking at a peak. Of course, you have some fine structure often, and so forth. So there's a lot of more information in a NMR spectrum, of course, than just where the peak is. So anyway.
Okay. So I wrote the question, and Dan said it's a little bit biased, and maybe I should have been more specific about whether it was a singlet or a multiplet type of thing. So, but often we see in the literature NMR spectra with 20 or 30 identifications pointing to a specific peak, and it's not often clear if they're using that single peak or multiple peaks to do the identification. All right. Well, thank you, everybody. Again, I think this is one of the neat tools that we have from doing this type of thing, that we can build a little bit better public opinion about, these general questions and or more specific questions. So we appreciate your feedback. So next on the list is we begin to open this up for questions. And I'm just going to do this in this mode. Dan, can you see my screen now?
Yeah, sure.
That has question and answers. This way I can edit mode and add that. So maybe we can switch over to the question answer screen at this point and begin to ask the questions.
Well, we have a number of questions from one person, Professor Feen.
All right.
Do you want me to read the questions, or do you want to do them, Lloyd? Or
well, I want to be able to see them. If you'll help me, usually they're bigger. Here we go. I've been able to make it bigger. Okay.
All right.
Okay. So I'm looking, there are several comments up top about technical questions.
Yeah, well, the first question is from Oliver saying, I guess such confidence scoring should or could be computed automatically from the data that authors report. And that's a question.
That would be wonderful if it could. It could be wonderful if we could auto-report it and auto-interpret it. At this point, we don't have that capability, but I'm sure somebody in the informatics community could. Can we bring Oliver in on the discussion and let him comment more?
Sure.
Can we unmute him?
Tanika, can you do that?
So I assume it will be under the attendees.
Okay. Unmute. I did it. So Oliver, you've got the microphone.
Oh, okay. Can you hear me now?
Yeah.
All right.
Yes, yes.
Okay. I just looked at this, and it's basically a scoring system that's based on the data you report, accurate mass and retention time and MSMS and whatnot. So that should be able to be picked up by a journal or a system rather than a self-reporting by the authors. And the reason is authors would like to self-report higher numbers, right?
Yes.
Or they would say, oh yeah, I give myself a 5 point whatnot. And it would be better if it's, or more objectively done, if it's done based on the tables or on the figures and whatnot, or, even the supplements, if they would have supplements and they say, for each compound, I had this retention time and this match and this library and this accurate mass and this isotope pattern or whatnot, right?
Yeah.
Because in principle that is possible to do. It's not a miracle, and it's mainly an Excel table that you can upload to a journal report, and from where then these auto computing would come, and then it would come for each individual compound you have, right? One compound could be a 5 point something, and the other one maybe only 3 point something.
Or if you had a tick box that you could just tick in, the different areas, that could also work.
Yeah, something like that. But you apply it to every compound, or just to some of them, or I think
so. I think we still have to be a little trusting of the authors to accurately report their, data. So if they wanted to cheat and give themselves a higher number, they could always still cheat and say, well, I did, tandem matching to an authentic standard and did NMR, blah, blah, blah.
Okay.
Yeah, and there's always wiggle room. I mean, there's always one of the things I wondered is, if I report I have matched the retention time, what is my window of uncertainty for the retention time? What is my window of uncertainty in the accurate mass? Do I allow 2 millidalton, 5 millidalton? And that might be a little iffy for some authors, or 10 millidalton, and all of a sudden I can identify anything I want, right?
So I think that one, it would be a very useful tool, and that's a project for somebody that's interested in informatics development.
All the journals. I mean, if the journals are interested.
Yeah.
Or the database guys, the KEBI and the metabolites and the workbench.
Okay. Well, hopefully we have some representation on here from some of the informatic groups, and that's a take-home message, is that here's an opportunity for some collaboration to pick this up and build some type of automated scoring tool. So it's a good suggestion. All right. Okay, moving down.
I can read this one from Vishwapara Misra.
Yep.
Is that okay? I'm going to unmute you and
or let him read his own question. If maybe that's a.
Yeah, if you want to do that. Vishwapara, are you there? We're not hearing you.
Okay.
Well, let me go ahead and start the question, and maybe it'll spawn a discussion. If you want to respond, you can hold your hand up, and I'm going to drop all the hands right now. But if you want to respond to the topic, just go ahead and raise your hand, and we'll try to recognize you. The statement is a majority of biomedical metabolomics literature still thrives and reports MS-MS-generated features without any true identification or annotation of metabolites, and attributing them as biomarkers/metabolites of interest associated to a disease condition. This is compounded with a lot of journals publishing metabolomic studies and usually in integration with other omics data. What could be the way out to bring all these submissions, journal articles, and cross disciplines under double quotes one umbrella with standard set of rules with possibly Metabolomic Society as the lead alongside other academic communities?
Well, that's an enforcement issue in my mind, that how do we get people to report their data in a specified manner. So I think that we need to further build consensus of what we want that data to look like and what the confidence and the reporting standards should be. Then, we need to act on them, and to begin to, as we begin to act on them, we begin to draw a standards line. Then people then begin to try to meet that standards line. Journals typically don't like standards because it decreases and complicates the review process, or decreases submissions and complicates the review process. So, but we have to show that there's value, and I think that as we standardize data, the ability to integrate this data with other omics technologies and things that you're talking about, biomarker discovery, then becomes important. So, but the idea of using just a tandem mass data as a biomarker, I think, is a good discovery point. But to make that anything of real practical value, you still have to identify that metabolite to understand that biomarker.
Okay, Robert Mistrick has raised his hand, so I'm going to unmute him and see what his comments on this question are. Robert, are you there?
Yes, I am here. Do you hear me?
Yes.
Yeah. Okay, first, Lloyd, thank you very much. This is really becoming a very, very interesting webinar series, so I really appreciate it.
And we appreciate your participation.
Yeah. First, Oliver raised a very important question about the scoring system. So each point of the scoring system can hold some potential problems. The exact mass just give you really a number of potential compounds, because if you search one exact mass at 0 ppm, you can get in Takehome between hundreds and thousands of compounds for known unknowns. So if you have unknown unknowns, you can get even millions. And the reason is the huge structural diversity of isomers. And second, even the spectra matching. If you match spectra at the wrong collision energies, you can get a perfect match with a completely different compounds. So therefore, I believe the community should specify in more details each point which should be associated with the scoring system. And still, I believe the community is doing some oversimplification of the problem. If you go to the old good mass spectrometry days, so you need one article to really reason why you believe this compound corresponds to these chemical structures. So because you may need fragmentation data, you may need a spectra of analogous compounds, you may need quantum chemical calculations, you may need authentic standard, and so on. So it's very, very difficult to identify even one compound. So we are regularly identifying, for example, forensic compounds. This is extremely difficult, even if you have compound in unlimited amount, you have all the methods, and to get the chemical structure is very, very difficult. So therefore, to further develop the system, we have to really clearly specify what we mean with retention time, what kind of methods have been used for spectra match and many other those stuff, because this will be purely subjective, and the number you put there, so you will get any result you wish.
Right.
So therefore there must be clear specification about every point, and that's very important, what I think.
I totally agree, and there's been some community discussion about it, even though I didn't talk on it today. The Chemical Analysis Working Group, in that original document, publication in 2007, does talk about reporting standards for these experimental parameters which you're discussing and saying are important, i.e. retention time, chromatography, mass spectrometry, the parameters associated with each of those, collision energies, ionization type of potentials, things of that nature. So in the broader context, I think that under the standards initiative, that these things have been discussed, have been agreed to be important, and then as we begin to interpret this data and move towards enacting this data, I think one of the ways that we could do that is begin to build templates. And long ago, I think I got from Oliver an Excel spreadsheet that began to try to get all of these into a template. And I think we've expanded upon that, and we always use this metadata sheet, if you will, as one of the sheets in our Excel files that we send to along with our publications. And so I think that's a way of enabling that. But if others have different ideas for enacting such needs, then I'm open. Would appreciate hearing from you.
Okay, let's go to another question. I'm going to mute you, Robert, so if you want to talk more, raise your hand. Next question is from Yasmin, and I'm sorry, I will murder the last name. Numerically, it's a practical question. I'm going to unmute you right now. The question is, in terms of scoring matching MSMS values, how many fragment matches would deem a match? Should it be based upon M sub Z matches, or should we also include intensity matches? I think that's a big can of worms, but
I think so too. I think matching the more peaks as well as the intensity of those peaks can increase your confidence. Many of the searching algorithms now, I do believe, dot product type things do take into account the number and intensity of the peaks that are matched. And so I don't want to reinvent the wheel there, but I think that we can rely on what's been done already. I think that another part of that is many of these searching algorithms have scores that go with them, output scores. And many of us have learned to judge those scores. And so if you report that I used the NIST library search and I got back a score of 62, then we can say, okay, well, most of us would be a little skeptical of a 62. So maybe including those scores in your reporting metrics is another idea of what we can do. And we've talked about that a little bit, but as Dan said, that's a big can of worms of trying to, also incorporate those scores. But I guess at the end of the day, I'm kind of supportive of the more information you provide, the better. And I think most would agree with that as well.
Yasmin, do you have anything to add or elaborate?
No, I was just curious in terms of developing the numeric score system, how will those differences like in intensities be judged? So it seemed like with the numeric system it was just given a certain number, but will it be if you have 5 matches that you'll get a specific score versus 3 matches?
Yeah. I don't think we've dug that deep yet, and I think this, Robert Mistrake also alluded to this, how do we, capture all of that information that goes into that identification. And so would you then, what would your suggestion and vote be? And how would you suggest that such, information was incorporated?
Wow, that's a pretty open question. Thanks for valuing my advice at all. But I would definitely want to match with the M over Z values for sure. But in terms of relative to intensity, we know that different operating mechanisms are going to have different intensities when you do the fragmentation and different collision energies, and sometimes that can be a challenge when you're trying to match them to certain databases. And so thus, I think that's a lot more of a complex issue, but there would be some value if we could develop a score system based on different platforms, and it might be a decimal or a fraction of a full score versus having just a single value.
Yeah. Well, again, I think that others are working in this area, and we've talked about some type of probabilistic or scoring system. I think there are others that have some concerns about that. Maybe ask Robert, unmute Robert, and see if he has any comments about the probabilistic type of scoring systems for matching tandem data.
Okay, Robert, you're unmuted.
Yeah. Well, yeah, thank you. Well, first, what kind of techniques you are using? Because if you are using CID, you get sparse spectra. If you are using HCD, you get very rich spectra. Some compounds yield 2 peaks. Some compounds, like steroids or fragile compound, yield hundreds of peaks. So therefore, as Lloyd correctly pointed out, there must be some logic built in the algorithm. So it should be proportional. Of course, if you have a spectrum of 2 peaks, then all 2 peaks must match. If you have a steroids, well, you cannot get a result where 100 or 200 peaks match perfectly. And this is a very, very important question with these collision energies. So, well, even perfectly tuned system, if you repeat scan by scan, you may see it. So the intensity is just varied from 1 second to another second, so therefore the matching algorithm should be able to compensate for this intensity. But what I really believe, to really make the objective criterion, we need a validation criteria. So therefore any database and any algorithm should be objectively validated, because this will always be only just our impression or our opinion and so on. So therefore I believe in the future any database and any algorithms should be validated, and validated on different types of data. So validated on a very small molecule which yield a few peaks, and validated on larger molecules and molecules that yield many fragments, and because you may get a completely different results. So, and that will be the decisive criterion between database and database. How your database was validated based on the searching algorithm. And you know, this is like judging the people by IQ. Well, it's very difficult to assign an IQ to a people and say everything about the person. And the same is with the searching algorithm. So, for example, in our database, we report three matching algorithms. So, you know, we still didn't find a way to generate one, because for one type of compound, one matching algorithm is better. For another type of algorithm compounds, another algorithm is better. So my message is never believe only one single algorithm. It's always better to have 2, if not 3.
Okay, I think maybe we should try one more question because we're coming up on the hour. Justin Vanderhoof has a question. Okay, how do you confidently, clearly communicate partially solved structures? For example, you know the elemental formula in a substructure with huge confidence. How are you going to report that so that people can find that as such?
Yeah. Well, that's a really tough one, and it is difficult to report partially known structures. There are some chemical terms, and I believe there are actually some SMILES ways of, codes ways of doing that. Maybe somebody that's more knowledgeable of INCHI codes and SMILE codes might comment. Oliver?
Well, I'm unmuted, I guess. So, well, first of all, thanks, Lloyd. Yeah. Well, first of all, thanks for your interesting presentation. Well, I asked the question because I think many of us get partly solved metabolites, and well, we give them a name like, oh, this is a camphorol glucoside, maybe.
Yep.
And if
We
we
do
can
that too.
communicate that with more clarity in terms of the structure, so actually that we know that there's a campral structure and an hexose structure present in this metabolite, then other groups can maybe say, oh, but we found the same thing because the fragmentation match, and we have also an NMR spectrum, so we can tell you it's campral 3 glucoside, for example. I mean, I also like the idea you mentioned earlier of labs working together on getting better metabolite annotation and ID levels. But anyway.
Okay, I'd like to chime in. This is a very good question. We face it every day in our lab, and there is no good way currently. The INCHIs do not give ambiguity mostly. So there's some ambiguity you can do, but mostly also for SMILES codes, you cannot nicely code ambiguity. The INCHI consortium has a trust where you can suggest panels to be formed, or also be member, and similar to the IUPAC, you would then have task forces to try to come up with better ways to clearly say in a structured way, in a computable coded structure way, what you know and what you do not know. I was asked to head such a panel, and I politely declined because it's a lot of work, right? So this is not funded work. And I think Stefan Neumann has declined and others. So this, when we asked Stephen Heller, who is kind of like chairing this INCHI consortium, so this question is open, it's up for debate, and I think it would be a perfect grant proposal. If I was an NSF officer or something, I would totally fund it, but right now there's nothing like that.
Yeah. Well, thinking a little bit more about it, if we step back away from the codes, the INCHI codes or SMILES codes or whatever, I mean, what we've been doing historically is we do report things as such as rutin glucoside or rutin hexose, where we don't know the stereochemistry of the sugar. But if we use the 4-level system, then we could actually add some type of quantifier or nomenclature for that identification confidence. And it would be, instead of an identified structure as a number 1, it would be a number 2 or a number 3, for example. And I think conveying that confidence is an important part of what we want to achieve. Now, how we actually do it then becomes, open to debate.
But I think that's also very good. It's just that if you know a substructure very confident, then you would like to somehow, say that or communicate that, right?
Yeah.
Yeah, and you want to communicate that in an electronic way that other people can see what you've communicated. Of course, you can always draw structures in a PDF, put it online as a supplement, but nobody sees that, nobody reads that.
Yeah. No, I know.
Yeah.
I believe there is some work underway for marker structure and INCHI code, and I think there is still a method for reporting only substructure or only partial structure. So you write a structure and put R as an unknown functional group or unknown part of the molecule. So because still the best way how to report the structure is a molecular structure, so mol file. So there isn't a better way, and it depends what kind of level uncertainty you would like to publish. So either you don't know the stereochemistry or you don't know nothing about a part of the molecule. Well, write substructure, put there R or 2 R's, and either you explain those are in the text or in a table, and well, this is partially reported molecule. Well, it's the simplest way how to do it currently.
Okay.
All right.
Great feedback. Great discussion. So we're on the hour. I would like to continue, but we understand that some people may be committed. So shall we just continue the questioning, Stan? And, at an hour and a half, we'll bring it to a formal close if we go that long.
Yeah, sure.
Okay.
Let's see. So Cedaram Good Immediate says, in GCMS metabolomics, saturation of the peaks is a potential problem. Maybe the journals should ask for original spectra for confirmed compounds from the authors.
Yeah. Many realize this. When you ask for original data from authors, there is a very substantial memory requirement that goes along with that. And I don't know of any journal right now that is willing to store such large data sets. Then maybe the alternative solution is that we are building public databases, repositories for metabolomics data, metabolites, workbench, others of nature. So my thoughts are that we should put the raw data in these public databases and then just submit the processed data to the journal, but also to the database as well. And that then allows and enables people to reinterrogate your data, look at these issues, and even if they want to look at metabolite identification, so they can look at saturation, spectral quality, noise levels, all of that if you post the raw data. So that's my general thoughts on that. Others' thoughts? Maybe we should just kind of open this up, unmute everybody so that we can have others comment on some of these issues.
Muted. Unmuted.
You unmuted. You muted everyone, I think. Okay. All right.
Bear with us as we try to resolve.
There's no unmute all button, Lloyd, unfortunately.
Okay.
Let me unmute Cedaram and see if there's any comment from there.
Okay.
Yeah, that's fine. I agree there should be some repository where everybody can keep their raw data, and people should have access to investigate the spectral quality.
Yeah, I think that's a general consensus, and again, we encourage people to put data out there, but I think many of the databases are not well funded, and there's not a clear long-term support for those databases either. So I think that we as a community, if we support that, then we're also going to have to be champions for supporting, financially, or conveying our support to the funding agencies so that there can be long-term funding and support of these, because it will take money. All right.
All right, so let's see, is Jan Stanstrup still on? Yes, okay. Let me read this question. I think that one thing that is missing in all these scorings, and what was also alluded to by Robert Mistrick, is some idea of how sure you are it cannot be something else. So your spectra can have a very good match, but there are 3 other compounds with almost the same match, your confidence is still low. You might not even have spectra for these 3 compounds that are also similar. Also, in many cases, you might have excluded some isomers. So that is useful information that there is no easy way to report now. So,
yeah, I agree, and I think this issue has also been addressed by other communities. So, for example, the proteomics folks, they do a false positive type of calculation using decoy databases. Maybe such a decoy database could be generated in the area of metabolomics, but how do we cover all of that chemical space? Ultimately, I think that is a grand challenge to define that overall chemical space, and then try to do what you suggest. And that is, we have good confidence that it's matching to this one compound, but how do we build confidence that it doesn't match to any other? So, anybody online that would like to comment on a false positive type of algorithm for metabolomics?
Well, I would like to say a few words then, because it also relates to the question I also asked. So about how many databases should you search in for possible candidates? Because if you only take one database, then your amount of false positives will be much lower than if you search in, let's say, 3 or 4 databases. So yeah, well, what you can always do is report a number of possible candidates, right? I mean, that's always something you can do.
You mean report the top 3 or 4 hits, if you will, or top or 3 or 4 scores, so that you build either a consensus or, alternative options?
Yes, or alternatively, if you say like, okay, there were 10 hits above this threshold, that that of course at the end of the day you need to somehow put an arbitrary threshold on the scoring if there's a scoring system, and then you can report the number of possibilities that database returns. So something like that I would imagine could work.
Yeah. Other ideas?
Well, yeah. Well, when we are talking about mass spectrometry, so we have to really be honest to ourselves. Mass spectrometry cannot distinguish certain positional isomers or structural isomers. So, for example, some ortho, meta, para, hydroxy group cannot be fully distinguished in mass spectrometry. So, strictly speaking, with the library search, you can exclude compounds which are not your analyzed compound, but you can sometimes hardly confirm the compounds. So, and therefore, people using library search should be aware about all these limitations. And there is less work done on the energy. So, at certain energies, different compounds looks absolutely identical. If you move to a different energies, then you can see the differences. So therefore, when we try to use library searching, we have to use all the possible information. So maybe MS to the third spectrum, maybe different energies, maybe other criteria, or even the small peaks can distinguish between two isomers. So therefore, mass spectrometry is a great method, very sensitive, but is not always very specific.
Yeah. Okay. Well, thinking about that, I often consider metabolomics a discovery type of platform. And in the discovery platform, I think there's a difference in rigorous that we need to identify compounds. Whereas once you have the discovery, you want to validate a biomarker, then going these really extra miles are necessary. So as a community, how do we then decide where that line draws and when and where? Is it fair to ask everybody to identify all of their compounds at such a high level of rigor, or do we have an acceptable platform for the discovery part, and a more rigorous platform or requirement at a biological interpretation point of view?
I think it depends on the research question and the type of experiment.
Yeah.
And as long as people use their common sense as well in terms of, hey, we find this candidate structure, but say it's a drug, and you are absolutely sure that the samples that you look into cannot contain that drug, then obviously don't report that, because you already know that it's not a true candidate. So I think if you know about the biology of your system, you can also exclude certain candidates, etc. But yeah, I don't know.
Okay, in the interest of time, maybe we should move on. We have other questions? Yeah. Dan, you still with us?
Yeah, I'm here. I was looking for Jan to pipe up, and I didn't hear anything from Jan Steinstrup. So, because you just posted another question about IUPAC working group. So, can you elaborate on that? Jan, if you're talking, I can't hear you.
He says he doesn't have no mic, so he can't talk. So
Oh, I see. Okay.
he just typing in questions. Well, thank you, Jan, for the feedback, and your input has been recorded as part of the Q&A type of session. So.
Okay. Good.
So again, moving on.
Yeah. So here's a question from Diana Santos Faria. Or a statement or a question. It says, so in targeted metabolomics, reporting the identification based on a reference library is not enough. So I guess that's a rhetorical question.
Now let's get her online and let her elaborate.
Are you there, Diana?
Yeah. Well, maybe if she's not going to comment, I'll comment quickly on it. Typically, in my view, targeted metabolomics have much more rigor in their identification, and typically I see this as a MRM type of experiment where you have a retention window, you have a quantifier peak and a qualifier peak, and the tandem data that you're using for targeted metabolite identification and quantifications. And I believe there is a lot of value in large-scale MRM or large-scale targeted metabolomics in our platforms and approaches as well. So I think that data that comes from them may be more, may go further to answer questions about biology and biochemistry. Any other thoughts? Diana, would you like to elaborate again or try to elaborate?
No microphone, Lloyd.
She doesn't have a microphone either? Okay, so. Okay, well, thank you, Diane, for the question. If you would like to add further comments in the through the electronic system, we will record those and keep it as part of the record. So, okay, Dan, next question.
Okay, let's go back to another statement or question by Oliver Feen. He said that theoretical MS-MS predictions are different in accuracy and certainly depend on the underlying algorithms, the number of available data to which the algorithms have been developed, and of course the compound class. So maybe some discussion of theoretical calculations.
Well, I believe that theoretical calculations should be based on empirical learning, i.e. we profile a class of compounds and then use those to predict future spectra. And I think that's been done a lot in the lipid area, and we've been working in the area of flavonoids and terpenoids to predict spectral as well. So Oliver, would you like to comment further?
I think he shows self-muted, so.
Well, let's try to unmute him.
No, I don't think you can.
Okay. Okay.
I don't see any other fresh questions. So if you have a question that we've run over or have any comments, raise your hand on the control panel there or type in a question. Otherwise, maybe we're winding down, Lloyd.
Yeah. Yep.
I don't see any hands raised.
Well, Robert's got his hand up.
All right.
Robert, you're live.
Yeah, thank you. For this theoretical spectrum prediction, it's true, Lloyd, what you said for a linear or semi-linear molecule where molecules fragment in a uniform manner. So you can really empirically predict the fragmentation, or you actually recognize the fragmentation pattern and try to apply this pattern for various combinatorially generated molecules. once you go to the small molecules with the rings or fuse rings and so on, there is no other way than the quantum chemistry.
Or to solve the structure via NMR.
Yeah, so the theory, what actually happens in a mass spectrometry is so complex. So one methyl group or hydroxy group can completely change the appearance of the spectra. So therefore the proteomics and lipidomics and all the sugars were very successful because there is a linear molecule and uniform fragmentation. And I don't think nobody succeeded yet in a small molecules, because without the quantum chemistry, that's my opinion, without the quantum chemistry, it's not possible.
Yeah. Well, we've done some work in the area of flavonoids, isoflavonoids, and terpenoids, and we've built tandem libraries of hundreds of flavonoids, for example. And these do have some general structural similarities, but I don't really know if I would call them linear type of molecules. But I do believe that we've learned a lot from doing the empirical, and that can be translated into some prediction tools. And my thoughts are that that's not a confident identification, i.e. a match to a predicted spectral library is not a confident metabolite identification, but it's a move towards the direction in solving that structure. And I believe ultimately, personally, that you need both mass spec and NMR to do full three-dimensional structural characterization for confident identification. And so the idea of just relying on mass or tandem mass is not enough. And so, but there seems to be some divide in the community. Many want to say that mass spectrometry is enough to do that, and your argument is kind of, I agree with, that maybe it's not often enough unless you have much more rigorous understanding of the fragmentation.
I think it very much depends on a case by case, right? And again on the biology or the chemistry of your sample. If you know that certain reactions cannot take place, that also gives so you don't need to explore all the possible options. If you apply.
Well, but it's very hard to say that we can exclude all reactions. We don't know the stereospecificity of 90% of the enzymes, for example. So it's very hard to prove a negative, if you will.
But still, over time, when we acquire more and more confident structures, we might be able to learn what the biology drops, right?
Well, I do agree that the biology can teach us about the potential chemical space there. I just think we have to be careful of defining that as the only possible chemical space.
Oh yeah, I fully agree, because we don't know what especially microbes are capable of. So.
Okay. All right. Well, thank you again for all the discussion and questions. I have 3:22, so we're beginning to wrap things up. I'll do a final call for questions, so if you will raise your hand in the next 15 seconds, we will try to get you in on the conversation. If not, I don't see any more hands, and so I'd like to bring this to a close. I'd like to thank you for your feedback, your participation, and your comments. And ultimately, another outcome of these types of webinars is that we begin to reinvigorate these discussions and build a discussion group. This can be a continuation of this group here and/or our collaboration with the Metabolomics Task Group. So as we continue this discussion, I would like to, build consensus and then ultimately possibly develop another white paper or publication that puts forward this consensus. So thank you, everybody. And we hope to see you again next time on the next discussion. Any final comments?
Thank you, Lloyd, for organizing.
Well, thank you. It's a community effort that we need to solve this. So take care, everybody. Have a good day, a good night, wherever you're at.
Good night.
Good night.
Bye all.
Bye.
Bye-bye.
Okay, goodbye.
Okay.
Had to prepare. But now it's the my last sprint, and then I get back again.
Okay, everybody. I'm trying to figure out how to close this down.
I'm going to do it.
Okay. Can you close it down and stop recording?
Yeah, I'm going to end the webinar.